Good morning, students. Beta, in maths, we are going to start cones topic, which is actually a part of a bigger topic, mensuration. So first, a cone is a solid that has circular base and a vertex. So it's a shape that is having a circular base and a vertex. In other words, a cone is a pyramid with a circular base. So it is a pyramid with a circular base. So this is the definition of the cone. In a right circular cone, the vertex is directly above the center of the circular base. So if the vertex is directly above the center of the circular base, this is called right circular cone. And otherwise it is called an oblique circular cone. And if the vertex is sideways, not right at the top of the center of the base, that will be called oblique circular cone. In a cone, the perpendicular height or the height is the perpendicular distance from the vertex to the base of the cone. So beta, from the vertex to the base of the cone, the distance will be called perpendicular height or will be simply called height. The slanting height is the distance from the vertex to the circumference of the cone, and the distance from vertex to the circumference is called slanting height. The radius of the cone is the radius of the base, and the base radius will be called the radius of the cone. Okay, beta, here are some formulas. The volume of the cone will be 1/3 into base area into height, and you have just looked at the shape of the cone. The base is a circle, so area of the circle is pi r square, and this height will be h. So 1/3 will remain as it is, base area will be pi r square, and height will be h. Curved surface area of the cone. Curved surface area, beta, this is called curved surface area, which is at the top of the circular base. And the formula for the curved surface area is pi r L. Total surface area of the cone is, ultimately there are two things. One is base area, that is a circle, and when we are going to find the surface area of the cone, that will be equal to curved surface area, that is at the top, plus base area. And curved surface area formula is pi r L. This will be placed in place of this, and base area is a circle, so base area will be pi r square. So the total surface area of the cone will be equal to pi r L plus pi r square. Okay, students, here is a question. A right circular cone has a base radius of 8 and a height of 15. So this is given in the question, and have a look at the figure. So base radius is 8 and perpendicular height is 15, which is given in the question. Now the requirement is slanting height of the cone. Okay, beta, this slanting height is the requirement missing, that is actually L. And if you look at the triangle, this is a right angle triangle, and in any right angle triangle, Pythagoras theorem can be applied because two sides are given, this side and this side is given, this is missing, so we are going to find this side. So Pythagoras theorem will be applied. Pythagoras theorem is hypotenuse square is equal to perpendicular square plus base square, and this is hypotenuse, so hypotenuse square will be L square is equal to perpendicular square, this will be equal to 15 square plus base square will be 8 square. And now you will solve these values on the calculator. This will be equal to 289. You will take the square root of both sides. This will be equal to L, and 289 square root will be 17. So L is equal to 17. This is the answer of the A part. B part is the volume of the cone. Now you will put the formula for the volume of the cone, which you have just studied before. Volume of the cone's formula is 1/3 pi r square h. Now you will put the values in this formula. 1/3 will remain as it is. Pi's value is 3.142, that is a fixed value, and r is 8. So 8 square will be put here, and h is perpendicular height, that is given 15. So 15 will be placed in place of h. Now you will solve these values on the calculator. Answer will be 1005.44, and volume is always in cubic unit, that's why you will put cube on the unit centimeter. So answer will be in centimeter cube. Okay, beta, last requirement of the question is the total surface area of the cone. Okay, beta, total surface areas of the cone, the formula is pi RL plus pi R square. Pi's value is 3.142, R's value is 8, and L's value you have find it out with the help of the Pythagoras theorem, that is 17. Like this one is 17. So put 17 in place of L. Plus sign will remain as it is. Pi's value is 3.142 and R's value is 8. So here we will put 8 square. Now solve these values on the calculator. Answer will be 628.4 centimeter square, because area is in square unit and unit involved is centimeter. So unit will be centimeter square. Okay, beta, next question is the volume of a cone with a circular base is 216 pi millimeter cube. This is the volume of the cone which is given in the beginning. If the base radius of the cone is 9 millimeter and the radius is also given, find the height of the cone, and height is the requirement. Okay, now look at this statement. Volume is given, so we will put the formula for the volume of the cone. So look here, volume of the cone is 216, which is given. We have put here. And now the volume of the cone formula is 1/3 pi R square. H is equal to, this thing will remain as it is. Now in the next step, 1/3 will remain same, pi will remain same, R is given, that is 9. Look here, radius is given 9. So here we will put 9 square because of R square, and h will remain as it is because height is the requirement. So this will remain as it is, and 216 will remain as it is. At this step, all these values will move to right side. Pi 9 square will come to the denominator, and this 3 will be multiplied with 216 pi, and at this step solve it on the calculator. You will get the answer 8. Unit will be millimeter because height is in singular unit. Next question statement is the diagram shows a sector AOB of a circle cut from a piece of the cardboard. The radius of the sector is 21. So this is the 21 of the cardboard paper, that is radius of the cardboard paper, and AOB is 150 degree, and this angle is 150 degree. The edge OA and OB are joined together to make a hollow cone. So this paper is going to be making a cone in the shape of the cone. So ultimately, this paper will be formed in the shape of the cone. This thing will become the slanting height of the cone, that will be L, and this thing will become the circular base of the cone. So requirement is the base radius. First thing which we are going to find is the length of the arc AB. Length of the arc AB formula is theta over 360 into 2 pi r. Here theta is 150 over 360 will remain same into 2 pi, and r value is 21. You will solve these values on the calculator. Answer will be 55. Now this sector area will be going to make the circular base of the cone, which will be 2 pi r and will be equal to 55, and from here we will find the value of the r. This will be 8.75. This will be the radius of the cone, which is the answer of the first part. Second part is the height. Now you will make a cone. Here is a cone. 21 is the slanting height of the cone. which is actually coming from here, because when this paper will be folded in the shape of the cone, this will become the slanting height, and this area, this thing will become the circular base. Okay, here is the cone. Slanting height is 21. Radius you have just find it out, that is 8.75. This is the radius, and the requirement is the height of the cone. Okay, beta, again you will apply the Pythagoras theorem, because again this is a right angle triangle. Height is missing, one side is missing, base and hypotenuse is given now. So formula is hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 21, that is equal to 21 square is equal to perpendicular square, that is a square, plus base square will be equal to 8.75 square. Again at this step you will use the calculator, and answer will become 19.1 centimeter. This is the height of the cone. And the third thing which is the requirement is the volume of the cone formed. So this is easy step now. Third step, you will apply the formula 1 by 3 pi r square h. This is the formula for the volume of the cone, and apply the values which has been finding it out now. Pi's value is 22 by 7, r's value is 8.75, and h is 19.1. So all these values will be put in the formula. Use the calculator. Answer will become now 1530 centimeter cube. The next question is, statement is a solid cone has a circular base radius of 10.5 meter and the total surface area is 940 meter square. Find the slanting height of the cone. Now look here, beta, total surface area is given, and you have just studied the formula of the total surface area of the cone formula is pi r L plus pi r square. This is the formula for total surface area of the cone, which is given, that is 940. So 940 will be equal to this formula, and from here we will put all the values which are given in the question. Pi's value is 3.142. Look here, this is given 3.142. So this value will be placed in place of pi. R is given, that is 10.5, and L is missing because you are going to find the slanting height of the cone. So L will remain as it is. This plus sign will be as it is. Pi's value is 3.142 and R's value is 10.5. So 10.5 square, 940 will remain same. At this step, use the calculator and L will be finding it out, that will be 18 meter. Here are some questions, beta. Cones. Find first part the volume and second part the total surface area of each of the following. For example, in this question, we are having perpendicular height, radius of the cone, and the slanting height of the cone. First requirement is volume. Volume formula is 1 by 3 into base area into height. 1 by 3 will remain as it is. Base area's formula is pi r square, because here is a circle whose area is pi r square, and perpendicular height will remain same. Now we will put values in this formula. R is 7, so 7 square will be 49, and height is 24. And at this point we will use calculator. So pi, here is pi, multiplied by 49 multiplied by 24 equal divided by 3. So answer is 1, 2, 3, 1, 1, 2, 3, 1.50. Unit will be centimeter cube. Okay, beta. Second requirement in the question is total surface area. Surface area's formula will be base area, which is pi r square, plus curved surface area. Formula is pi r l. Okay, pi will be taken as common. Here will be r square. R square will be 49. R is 7 and L is 25. And now we will solve this on the calculator. 25 into 7 plus 49 multiplied by pi. So the answer is 703.72. 703.72. Unit will be centimeter square. Okay, bete, in this part, perpendicular height and slanting height is given, radius is missing, but this is a right angle triangle. So first we will apply the Pythagoras theorem to find the radius of the circle. Pythagoras theorem is hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is given, that is 18.2, so its square. Perpendicular is 16.8, so its square, and base is missing. Now we will solve this on the calculator, and that will be 18.2 square, and this 16.8 square will be subtracted from this one. 16.8 square equal to 49. So base square is 49, and then take the square root of both sides. That will be 7 millimeter. So this is 7 millimeter. Okay, now the requirement is find the volume and the surface area of this thing. Now we are able to find the volume. So volume's formula is of the cone is 1/3 pi r square h. 1/3 will remain same, pi is there, and r is 7, so its square is 49, and h is 16.8. Now we will solve it on the calculator. This is pi multiplied by 49 multiplied by 16.8 divided by 3. So the answer is 862.05. Unit will be millimeter cube. And the next requirement is find the surface area of the cone. Surface area's formula will be base area, that is pi r square, plus curved surface area, whose formula is pi r l. Pi will be taken as a common. R square will be 7 square is 49, plus r is 7 into l is 18.2. So this will be solved on the calculator now. 18.2 into 7, 18.2 into 7 plus 49 multiplied by pi. So the answer is 554.18. 554.18. Unit will be millimeter square. Here is another question. The requirement is same. Find the volume and the surface area of the cone. Now we are having perpendicular height and the base area is given, but slanting height is missing. So first we will find the missing values. Like base area is given, that is 38.5, and base area's formula is pi r square. That will be equal to 38.5. And from here we are going to find the value of r. So use the calculator. 38.5 divided by, this pi will be divided, so divided by pi, this is the value of r square, so we will take the square root of this thing. Answer is 3.5. So the radius of the cone is 3.5. Unit will be centimeter. And now we are able to find the volume of the cone. Volume of the cone's formula is 1 by 3 pi r square h, but still h is missing. So apply the values in this formula. 1 by 3, pi will remain same, r is 3.5, so 3.5 square, and h is 8.4. Now use the calculator. 8.4 multiplied by 3.5 square multiplied by pi equal divided by 3. Answer is 107.76. Centimeter cube will be the unit. But before finding the surface area of the cone, we are missing actually the slanting height. First we will find the slanting height by applying the Pythagoras theorem in the equation. Pythagoras theorem is hypotenuse square is equal to perpendicular square plus base square. Hypotenuse square is missing, this will remain same. Perpendicular of the cone is 8.4, so it's square, and base is the radius, that is 3.5, so it's square. At this point find the calculator, and at the same time we will take the square root so that we can find the hypotenuse. So 8.4 square plus 3.5 square equal, and take the square root of this value, that will be 91. That is 9.1. Unit will be centimeter. So now we are able to find the surface area of this question. Surface area's formula for the cone is pi r square plus pi r L. Pi r square is directly given, that is base area, so we don't need to solve it again. So we will put 38.5 because that is base area given, and plus pi r L. Pi r is 3.5 and L is 9.1. At this point we will use the calculator, and this is 9.1 multiplied by 3.5 multiplied by pi equal plus 38.5, and the answer is 138.56. Unit for the surface area will be centimeter square. So question number 20. The volume of a cone is 675 centimeter cube. Given that the base area of the cone is 150 centimeter square, find the height of the cone. First we will draw the cone. Base area is 150. So base area is a circle whose formula for the area is pi r square, that is given 150. From here we will find the value of r by using the calculator. 150 divided by pi, and take the square root of this value. This will be 6.90, yeah, 6.91. Unit will be centimeter. So the radius of the cone is 6.91. Centimeter. Okay, now the volume of the cone is 675. Volume of the cone is, formula for the volume of the cone is 1 by 3 pi r square into h. 1 by 3 will remain same. This is the area of the base, which is given 150, and h is missing, and volume is given, that is 675. So at this point, use the calculator. This 3 will be multiplied by 675. 675 multiplied by 3. And this 150 will be divided by the value, divided by 150. And answer is 13.5. Unit will be centimeter. In B part, find the base area of the cone if height is this and the volume is this. So volume of the cone is given and height is this. So volume of the cone's formula is 1 by 3 pi r square into h. Volume is given, that is 2112. 1 by 3 will remain same. Pi is there. R square is missing because this is the requirement. And height of the cone is 14. At this point, use the calculator and we will find the radius. So 2112. This 3 will be multiplied. Pi and 14 will be divided by the value. So divided by pi and divided by 14. So this is the answer of the r square. We will take the square root of this value. That is 12. So r is 12. And unit will be centimeter. In D part, find the base radius of the cone if its slant height is 12.5 and the curved surface area is 275 centimeter square. So we take curved surface area is given, so we will put the formula of the curved surface area, that is pi rl. Curved surface area is given, that is 275. This is the value. So here is equal to, pi will remain same, r will remain same because r is the requirement, and slant height, that is l, is given, that is 12.5. So values are being put in the formula, and now we will use the calculator, and from calculator the answer will be 7 centimeter. In G part, the total surface area of the cone of the base radius 28 centimeter is this. So total surface area of the cone is given. So we will put the formula of the total surface area. So base radius is pi r square and curved surface area of the cone is pi rl. So this is the total surface area of the cone's formula, which is equal to 5500. And now put the values in this formula. Pi will be taken as common. So here is r square now, and radius is 28. So here will be 28 square plus here is r. So 28 will be here. and find the slant height. So slant height will remain as it is because this is the requirement. So values are being put in the formula, and now use the calculator. Okay, this pi will go to right side and answer will be 550 divided by pi. Answer is 1750.7. 1750.7. And here are the values: 28 square plus 28L. So now 28 square will move to right side. So 1750 minus 28 square. Answer is 966.7. And now 28 will move to right side. So divided by 28. Answer is 34.53. Unit is centimeter. So this is the answer. In question number 21, statement of the question is draw a net of the following open cones and label its dimensions. Okay, bete, whenever requirement is draw the net, so remember one thing, this slanting height will become the radius of the sector when this will be opened. So radius of the sector will be 18 centimeter, and angle of sector so remember 2 pi, place 2 pi and 2 pi, like 2 pi divided by 2 pi. In numerator we will put the value of the radius of the circle, and in denominator we will put the slanting height multiplied by 360, and now use the calculator. This 2 pi will be cancelled by 2 pi. 9 ones are 9, 9 twos are 18, and 2 ones are 2, 2 8s are 16, and 0. So the answer is 180 degree. So now use these two values to draw the net of this cone. Radius of the sector is 18 and angle of the sector is 180. So 180 means that half of the circle will be there, like this. And radius is given, that is 18 centimeters. So this is the radius, 18 centimeter. And 180 degree shows half of the circle is given. So this is the net of A part figure. So here is a B part. Again, cos radius of the sector. That will be the slanting height, that is 20 centimeter. And now find the angle of the sector. That can be found out by placing 2 pi divided by 2 pi. In numerator, place the radius of the circle of the cone, and in denominator, place the slanting heights value, multiply by 360. And now solve the value on the calculator. This 2 pi will be cancelled by 2 pi. 5 ones are 5, 5 fours are 20, and 4 nines are 36. 0 will remain as it is. 0 will be placed. So angle of the sector will be 90 degree. This 90 degree shows that there will be a quarter of the circle. So this is the net, and radius is 20 centimeter. So this is 20 centimeter, and this 90 degree shows this is a quarter. So this is the net of this figure. Statement of question number 23 is the top part of the cone is removed. So this part is going to be removed, leaving the solid known as frustum of a cone. Find the volume of the frustum, giving your answer in terms of pi. Okay, Betty, this part is going to be removed. So it means that first we will, like requirement is the volume. So the required volume is first put the formula of the original cone, that is pi r square into h, because we have used capital letters for the original cone and this is a small cone which is going to be removed. So minus this small cone is going to be removed. Formula is pi r square into h, and now place the values. First 1 by 3 pi will be taken as common. Here is r square. R square will be the original cone's radius, that will be 64, and original height of the cone is 24, minus this r will be the radius of the cone which is going to be removed, that is 3. So 3 square is 9, and this h will be, small h will be 24 minus 15, that will be 9 centimeter. So 9 multiplied by 9, and at this point use the calculator. So 81, sorry, 64 multiplied by 24, 64 multiplied by 24 equal, minus 9 nines are 81, multiplied by divided by pi, divided by 3. Now use the calculator. 64 into 24, minus 81. This is the answer, divided by 3. Answer is 485. Pi will put with it because requirement is giving your answer in terms of pi. So this is the answer. Unit will be centimeter cube. Question number 24, statement of the question is a cylindrical wax candle of radius 6, a cylindrical. So here is a cylinder. Of radius 6 and height 24. Radius 6 and height 24. Is melted and reshaped into a solid cone. So this is going to be melted and reshaped in cone of radius 9. Find the height of the cone. So this is the requirement. But remember one thing, this full cylinder is going to be melted into, to reshape into a cone. So volume will be same, like volume of cone will be equal to volume of cylinder. Now put the formulas of the shapes. Volume of the cone is 1 by 3 pi r square h, and volume of the cylinder formula is pi r square h. This r square, okay. Now put the values. Volume of the cone 1 by 3, pi will remain same. Radius of the cone is given, that is 9, so r square will be 81, and h is missing. This will be placed as it is. Now pi on the right side. Radius of the cylinder is given, that is 6, so 6 square will be 36, and h of the cylinder is 24. This pi will be cancelled on both sides, and now use the calculator and solve the values. So 36 multiplied by 24, 36 multiplied by 24 divided by 81 and multiplied by 3. Answer is 32. Unit will be centimeter. Statement of question number 25 is a solid rectangular metal pyramid of base measuring 27 centimeter by 16 centimeter and height is melted and recast into a solid cone of height 14. It means the pyramid is going to be recasting into cone. So volume of the pyramid will be equal to the volume of the cone. So it means volume of cone will be equal to volume of pyramid. Now put the formulas of the shapes. Volume of the cone is 1 by 3 pi r square h, and volume of the pyramid is 1 by 3 into base area into height. Now apply the values. 1 by 3 will remain as it is, pi will remain as it is. Radius of the cone, okay, height is given of the cone, radius is missing, so r square will remain as it is, and height of the cone, that is 14, so h is 14. On the right side, 1 by 3 will remain same. Base area of the pyramid is a rectangular pyramid, so the base area will be 27 into 16. Length into width will be formula. A formula is applied here, and height of the pyramid, and height is 33. Okay, now cancel some values. 1 by 3 will be cancelled on both sides, and now find the r square. Okay, on right side 27 multiplied by 16 multiplied by 16 multiplied by 33. 27 multiplied by 16 multiplied by 33 equal to this. This 14 will be divided by the value, divided by 14 divided by pi. So 324.13. This is the value of the r square, and r will be, take the square root of this value. This is 18. Unit will be centimeter. So this is the answer of A part. Okay, bete, B part's requirement is the total surface area of the cone. Okay, total surface area of the cone. Formula will be pi r square plus pi r l. So apply the values now. Radius of the cone is 18, so this will be 18 square. This pi will remain same, r is 18, and l is, so the l is missing. First we will find the l. So draw the cone. Radius of the cone is 18, and height of the cone is 14. So apply the Pythagoras theorem here. That is, hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is missing, that is a square. Perpendicular is 14, 14 square
plus base is 18, so 18 square. Again use the calculator and find the value of h. That is 14 square plus 18 square equal. Now take the square root of the value. So this is the value of h. That is 22.8. This is slant height. So L is 22.8. And now apply the calculator. Now use the calculator at this point. This is 18 square into pi. 18 square into pi equal to, this is 1017.87. 1017.87 plus solve this factor. This is pi into 18 into 22.8. Value is 1289.31. And finally solve these two values. Plus 1017.87. Answer is 2307.18. This is surface area, so unit will be centimeters square. Statement of questions 26. A conical container of radius this and height this is completely filled with water. All the water is in the conical container is poured into a cylindrical tank with base radius is this. Find the depth in meters of water in the cylindrical tank. So a conical container's volume is going to be poured into the cylindrical tank. Requirement is find the depth of the water in the cylindrical tank. So first, volume of cylinder will be equal to volume of the cone, because full volume of the cone is going to be poured in the cylinder. Volume of the cylinder formula is pi r square h, and volume of the cone's formula is 1 by 3 pi r square h. Okay, now put the values in the formula. Radius of the cylinder is 1.5, so this will be 1.5 square, and depth is missing, that is h is missing. On the right side is cone. Now put the values in the cone's formula. Radius of the cone is given 90 centimeter, because units required is meter, so this will be divided by 100 to convert it into meters. This will become 0.9 meter, and height is 3.5 meter. This is already in meter, so put this value 3.5, and at this point use the calculator, but first cancel the value pi on the both sides. So this h will be equal to 0.9 multiplied by 3.5, 0.9 multiplied by 3.5 equal to this divided by 3, and this factor will move to right side, so divided by 1.5 square, and the final answer is 0.47 meters. The statement of question number 27 is the diagram shows a canvas tent made up of the cylinder and a cone. The diameter of the cylindrical part is 24. So this is the diameter of the cylindrical part, and height is 11. So this is the height of the tent. If the vertex of the cone is 16-meter high, so look at this value, this is 16-meter high. Find the total surface area of the tent. It means we are going to find the curved surface area of the cylinder and the curved surface area of the cone. But in curved surface area of the cone, formula is pi r L, so L is missing, slanting height is not given, but we can find the perpendicular height by subtracting 16 minus 11. So this will be 5 meters. But slanting height is missing, so first we will find the slanting height. Radius of the cone is 12. So apply the Pythagoras theorem on this right angle triangle. That is, hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is missing. Perpendicular of the cone is 5, so 5 square will be 25. Base of the cone is 12, so 12 square will be 144. And when this will be added, it will be equal to 169. Taking the square root on both sides, h will be 13 meters. So at this point, we can find the total surface area of the tent now. That will be equal to total surface area is equal to, formula will be like curved surface area of the cylinder, formula is 2 pi r h. And the curved surface area of the cone, formula is pi r L. Now put the values in the formula. 2 into pi, r of the cylinder is 12 and h of the cylinder is 11. Now cone, pi will remain same, r of the cone is 12 and L of the cone is 13. Now use the calculator at this point. 2 pi 2 pi multiplied by 12 multiplied by 11. Answer is 829.38. 829.38 plus, now this will be solved, 12 pi multiplied by L, that is 13. 12 pi multiplied by 13. Answer is 490.09. Add these values. Answer is 1319.47. Unit will be meter square. In this question 28, the solid shown is made up of two identical cones. So there are two cones which are identical and a cylinder. Calculate the total surface area of the cone. So beta, total surface area of the cone, there are two cones. It means we have to find the curved surface area of the cone and the curved surface area of the cylinder. So because cones are identical, so the total surface area will be equal to one cone's curved surface area, formula is pi r L, because there are two cones, so we will put 2 with it. And there is a cylinder as well, whose curved surface area's formula is 2 pi r h. And now put the values in this formula. This 2 pi will remain same. R of the cone is 7. And L is missing. So first we will find the L of the cone by applying the Pythagoras theorem, that is hypotenuse square is equal to perpendicular square plus base square. Hypotenuse of the cone is missing, radius is 7, and height of the cone is 90 minus 42 divided by 2. So this will be the height of the cone, 90 minus 42 divided by 2. So 24 is the height of the cone. So now apply these values in the Pythagoras theorem. Perpendicular is 24. So it will be 24 square. Base is 7. So 7 square. Now use the calculator. 24 square plus 7 square equal to this. Take the square root directly. So this is the value of h, that is 25. Unit will be centimeter. So this is L. Now apply this L in the formula, that is 25 plus this 2 pi will remain as it is. Radius of the cylinder is again 7 and h of the cylinder is 42. Now use the calculator. 2 pi multiplied by 7 multiplied by 25. Value will be 1099.56. Now solve this factor. 2 pi into 7 multiplied by 42. Answer is 1847.26. Now add these two values plus 1099.56, which is equal to 2946.82. This is the total surface area. Formula unit will be centimeter square. This is the A part of the question. Now B part. Find the volume of the solid. So there are two identical cones. So total volume of the solid is, cone's volume formula is 1 by 3 pi r square h. Put 2 with it because there are two cones, and there is a cylinder in between them. Formula for cylinder's volume is pi r square h. Now put the values. 2 by 3 pi will remain as it is. Radius of the cone is 7, so it will be 49. Height of the cone is 24. Plus here is cylinder, pi will remain as it is. Radius of the cylinder is 7, so it will be 49 r square, and h of the cylinder is 42. And now solve these values on the calculator. 2 pi multiplied by 49 multiplied by 24. Divided by 3. So this is the answer of the cones, 2463.01. And now cylinder, pi multiplied by 49, pi multiplied by 49 multiplied by 42. Answer is 64, 65. 0.3 like 0.40. Now add these two values. Plus 24, 63.01. Answer is 8928.41. This is volume, so unit will be centimeter cube.
Statement of question number 29 is,
The sides OA and OC of a semicircular sheet of the cardboard OABC, here is OABC, center O of diameter 36 centimeter, are joined to form a conical party head. Find the slant height. Okay, bete, the method when net is given and requirement of the cone is to find the slanting height. Slant height is the half of the diameter of the net. That will be equal to 36 divided by 2. That will be equal to 18 centimeter. Now B part is curved surface area. Curved surface area of the cone of the net is area of sector this is like semicircle's formula is pi r square divided by 2. Now put the values in this formula. Pi will remain as it is. R is 18, so 18 square. This 2 will remain as it is. Now solve it on the calculator. 18 square divided by 2. Answer is 162. And this pi will put with it. So this is the curved surface area of the cone. Unit will be centimeter square. And the final thing which is required is base radius. This is C part. Okay, now curved surface area of the cone is given. Curved surface area of the cone's formula is pi r l, and the value is 162 pi. Pi will be cancelled on both sides. Radius is the requirement, and slanting height is 18. 162 will remain as it is. Use the calculator at this point. 162 over 18. 162 over 18. Answer is 9. Unit will be centimeter. Question number 31 statement is, Mark used a rectangular sheet of art paper measuring 65 and by 41 centimeter to make a cone of height. Height of the cone is given. That is 40 centimeter. And from here, when this paper is going to be cut in the shape of the cone, so this 41 will become the slant height of the cone. This is 41 centimeter. Okay. The diagram below shows the amount of the paper left. A part, the area of the circle used to form the base of the cone. Okay, this circle is going to be the base of the cone. If we are required to find the area of the circle, it means first we have to find the radius of the circle. So this thing is going to be required. So first we will find the radius of the circle of the cone. So Pythagoras theorem will be applied. Hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 41, so it will be squared. Perpendicular is 40, so 40 square, and base is missing. Now use the calculator. 41 square minus 40 square, take the square root of this value, so it will be the value of the radius, that is 9. Unit will be centimeter, so this is 9. Now in A part, requirement is the area of the circle. From the base of the cone, so area of base of cone, formula will be pi r square. Pi will remain as it is. R is 9, so it will be 81. So 81 pi centimeter square is the base area of the cone. Okay, beta, in B part, we are required to find the amount of the paper left. Okay, now paper left will be paper left. So total paper is 41 into 65. From this paper, curved surface area of the cone is subtracted, that is pi r L, and also the base of the cone is subtracted, that is pi r square. Now apply the value. 41 into 65. Pi will remain as it is. This is the R of the cone, and R of the cone is 9. L of the cone is 41. Pi will remain as it is. R of the cone is 9. Now use the calculator at this point. 41 into 65. This is 2665. Minus 41 into 9 into pi. Answer is 1159. .25 minus 81 pi. This is 254.47. 254.47. Solve it on the calculator. 2665 minus 1159.25 minus 254.47. So answer is 1251.28. So this is the paper left. Question number 32. The statement of the question is a solid is made up of the cone and the cylinder. The slant height of the cone is 15. This is given. The height of the cylinder is 24. Okay. And the base area is 81 pi centimeter square. Calculate the base radius of the cone. So beta, base radius is missing. This is the requirement. Base radius. Okay, here is the base radius of the cylinder is given. That is pi r square is equal to 81 pi. Pi will be cancelled on both sides. Take the square root on both sides. This will be 9. Unit will be centimeter. So this is 9. Okay, first part is done. Second part is find the volume of the solid. So this solid is actually made up of a cylinder with a cone on the top of it. So volume of the cylinder is pi r square h, and volume of the cone is 1 by 3 pi r square h. Okay, put the values in this formula. R will be 9, square is 81. Height of this cylinder is given, that is 24. 1 by 3 will remain as it is, pi will remain as it is. R of the cone is as the same radius of the cylinder, that will be 81. But at this point, look, h is missing of the cone. So we will apply the Pythagoras theorem to find the height of the cone. That is, hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is 15, whose square will be 225. Perpendicular is missing. Base is 9, whose square will be 81. And from here we will find the perpendicular. Like 225 minus 81 equal to, take the square root of this value directly. So 12 is the perpendicular. So this is the height of the cone, and apply the value 12 at here. Now use the calculator. This will be 81 pi multiplied by 24. Answer is 6107.26. Solve it on the calculator. 81 into 12 into pi divided by 3. Answer is 1017.88. Now add these two values plus 6107.26. Answer is 7125. .13. Unit will be centimeter cube. So this is second part done. Okay, bete. Next part is, जाए अभी मैं काम कर रहा हूँ. Next part is the total surface area of the solid. This is second part. Third part is total surface area. So curved surface area of the cylinder is total surface area. Curved surface area of the cylinder is 2 pi r h, and curved surface area of the cone is pi r l. Now put the values in this formula. 2 pi, r is 9, and h of the cylinder is 24. Pi, r is 9, l of this cone is 15. Solve it on the calculator. 2 pi multiplied by 9 multiplied by 24 equal to 1357.17 plus 9 into 15 into pi, 9 into 15 into pi, 424.12. Solve it on the calculator. Plus 1357.17. Answer is 1781.29. Unit will be centimeter square. Okay, bete. Now B part is, given that the metal used to make a solid has a density of this, calculate the mass in kilograms. Okay, now volume is, we have find out the volume, density is given, and requirement is mass. So formula used will be density is equal to mass over volume. Density is given, that is 7.5. Mass is the requirement, and volume is 7125.13. Multiply these two values. 7125.13 multiplied by 7.5. Answer is 53,438.475. Unit will be grams, but the requirement is in kilograms. We will divide this value by 1000, so answer will be 53.438 kilograms. This is the answer.